Okay, we're going to do all 100. I think it's 100. Maybe there's more than 100. Let's take a look. He says 100. This guy always goes over 100, though. 101 questions. It's a lot of questions to get through. And it's about students returning to school, needing some review with how to solve a simple linear equation. And we're going to start off at the beginning. Start with question number one, go question number two, blah, blah, blah. And I'm going to do it in parts, though. I'm not going to do all 101 in one shot. So I want to go to the whiteboard and start the problem set. All right? Let me just get to the whiteboard here. And right over here. So I'll put down number one for you. And the instructions are solve for x, by the way. And this is a one-step operation. Now, by the way, looking at both sides, just the left side and the right side, they're certainly not equal. However, there's a condition that makes them equal, and that condition is there's some condition on x. Well, if you thought about it, x plus 8 would be 24. I'm going to say if you gave it a little bit of thought, you'd say, oh, probably x is 16. Right, and you could check this. Let me check it over here. Again, this is just thinking through it right now. What do you get? 16 plus 8 is 24. And that's correct, by the way. Now, let's talk about the procedure we want you to follow, which is simplify both sides first. Well, it's just simple. And then variable on one side, x is the variable, that's on one side, and the constant on the other, by adding or subtracting a constant from both sides. So I'm going to subtract 8 from both sides. And what do you get on the left side? You get x. On the right side, 24 minus 8 is 16. All right, let's go to number 2. And number 2 is x minus 15 equals, I can look back at the sheet, equals 27. All right, what I'm going to do here is, look at it. Again, some people can look at it and they could think of this over here. And they can say, oh, I could think what the answer is. And I'm going to say 42. All right, could we check that? Well, let's check it. It's going to be a check. Again, it's just thinking through it. And you say 42 minus 15 equals 27. Let's see if that's true. And again, it's 42 minus 15. Let's see, 32. Yeah, 27. This worked out beautifully. All right, let's talk about the other procedure we'd like you to follow. And that's simplify both sides. Both sides are simple as they come up. What are you going to do now? Get the constant on one side? Well, that's already done. And the constant on the other by an addition or subtraction of a constant term. I'm going to have 15 on both sides. What do you get on the left side? X. On the right side, 15 and 27. Let's see, 5 plus 7 is 12. Carry the 1. I'll give you 42. We're getting the same answer no matter what we do, by the way, whether we're thinking or using some stepwise procedure to solve for x. Let's go to problem number 3. And number 3 is a decimal number. It's 0.2 equals 40. This is where a lot of students bog down. The additions and subtractions are fine, but they bog down with this. I just want to go through, if you know the answer, you write it down, by the way. You say, oh, x is, and then you could check it, of course. All right, but I want to go through some work over here. And the work I want to go through is, if we look at this, let me get my eraser out. And we'll talk about checking it as well, by the way. Just checking these things. Let me try to get my eraser out. Oh, it's over here, that's why I couldn't see it. I'm going to point out what we're doing over here is we're just kind of looking at it and trying to get the x alone. And it's got a coefficient of 0.2. And one way to do that, it's a multiplier, by the way, is to divide it away. So I'm going to divide both sides by 0.2. And it's considered a one-step operation. Now, I want to go through this over here. This is 40, and it's divided by, now 0.2, I'll write that over here, and this is going to be 40 divided by, well, 0.2 is 2/10. Then I'm going to say 40 over 1 times 10 over 2. And what does that give you? Well, if you thought about it, 2 goes into 2 one time, goes into 40 20 times, and 20 times 10 is 200. So the answer is 200. All right? Put a box in that. Now, I'm going to check it. You always check it back in the original. This is the original. You take this number, 200, plug it in over here. You're going to get 0.2. I actually prefer to write down the fraction. That's 2/10 times 200. And they said that's equal to 40. Let's take a look at that. And, 10 goes into 10 once, and it goes into 200 20 times. And 2 times 20 is 40. That one's done. Let's go to problem number 4. And again, I got to look at the sheet. I can't remember these questions. Problem number 4 is x divided by 7 equals 6. Again, if you thought about it, you might say, oh, I think the answer is 42. That's fine. You could check it. Again, if you can't do that, you would not do that. It's 42 divided by 7, and that does equal 6. So this is the correct answer. But let's go through the procedure, and you get x over 7. Whoops. X over 7 equals 6. And again, the x, both sides are pretty simple, by the way, and the x is on one side, but what I need to do is get rid of that, that divisor, which is 7. And the way to do that is you multiply both sides by 7. I'll write that down for you. Now, if you do this over here, I'm going to write 7 over 1. The 7's cancel, and you're left off with x, and 6 times 7 is 42, as expected, by the way. Let's go to problem number 5. And number 5 is 3x equals 1/5. Again, these are one-step operations. If you know what the answer is, you write it down. Now, again, for a lot of students, it's tough to know what the answer is. But if I look at this, I'm going to say, looking at it, it looks like x is 1/15. Let's just check it. 3 times 1/15. Well, 3 is the same thing as 3 over 1, and that does equal 1/5. And why is that? 3 goes into 3 once, and goes into 15 5 times. You're left off with 1/5. Let's go through the work, though, and I'll point out what the work is. The x is on one side already. Multiply both sides by 1/3. Again, it's a multiplier of 3. We're getting rid of it by multiplying by 1/3. But both sides have to be multiplied by 1/3. You can write the 3 as 3 over 1 if you want. This gives me x, because the 3's cancel. 1 times 1 is 1. 5 times 3 is 15. We're still getting the same answer, no matter what we do. Let's go to problem number 6. And number 6 is minus 8 plus 11. I'm sorry, not plus 11. I made a mistake there. Let's write that again. So it's, let me get my pen back. It's minus 8 plus x. And again, if you look at this and know what the answer is, you just write it down. Now, if you think about it, it's going to be 19. And the reason for that, minus 8 plus 19 would be 11. You could check that. Let me point that out to you. Minus 8 plus 19 equals 11. And that's true. Let's go through the work, though. Again, these are one-step problems. What do you do? Add 8 to both sides. What do you get? X equals 19. All right, let's go to problem number 7. And number 7 is 45 equals 54 plus x. Again, if you gave it a little bit of thought, I hope you realize x has to be minus 9. If you want to check it, you just write it down. 45, 54 plus minus 9. 45. 54 minus 9 is going to be 45. All right, let's go through the work, though, and I'll write this down for you. It's a one-step process, by the way. These are one step. What do you do? Take away 54 from both sides. And what do you get on the right side? X. What do you get on the left side? Well, if you took 54 from 45, you're going to get minus 9. All right, let's go to problem number 8. And number 8 is minus 10 equals x over 2. Well, looking at this thing, I'm going to say x is minus 20. I could check it. Minus 10 equals minus 20 divided by 2, which of course is minus 10. This does work out. Let's talk about the procedure, though. Minus 10 equals x over 2. I would multiply both sides by 2. 2 is a divisor. Now 2 is a multiplier. So I'm going to multiply this side by 2 as well. It's fair and equal treatment. What do you get? Minus 20. That's easy. Over here, I'm going to write as 2 over 1. The 2's cancel, and you're left off with x. So x equals minus 20. Now, I realize some people are saying, oh, x on the left or right. It doesn't matter. It's always read from the letter x, by the way. X equals minus 20. Whether I read it here or there, I always read it as x equals minus 20. Let's go to number 9. And number 9 is 3/2 equals x plus 1/2. Again, it's a fraction problem. It's a one-step problem. I would subtract 1/2 from both sides. What do you get? X equals, well, we get 2 over 2, because 3 minus 1 is 2, and 2 over 2 is just 1. I want to check it for you, and this is going to be 3/2, equals 1 plus 1/2. Well, 3/2, 1 is 2 over 2, and 2 over 2 plus 1/2 is 3/2. All right, let's go to problem number 10. And what's number 10? Well, you got minus 4x equals 26. All right. Again, if you thought about it, you probably come up with x, but I'm saying right now, what I'm going to do is divide both sides by minus 4. What do you get on the left side? X. On the right side, what do you get? Well, you get a negative number, and you get 26 over 4. This should be reduced to minus 13 over 2. So I'm going to say x equals minus 13 over 2. I want to check it, and what do you check it back in the original equation? And this is problem number 10. So it's minus 4 times, I believe x is minus 13 over 2, and they claim that's equal to 26. Let me write this as 2 over there. I'm sorry, not 2. I'm sorry, I didn't mean to say that. I meant to say 1. Sorry about that. So if you look at this thing, if you just multiplied it out, well, 4 times 13, that's 40, and 12, which is 52. Again, negative times a negative is positive. And 1 times 2 is 2. And 52 divided by 2 is 26. It does work out nicely. Let's go to problem number 11. And what's number 11? Minus 8 equals 11 plus x. One-step problem, subtract 11 from both sides. What do you get? Minus 19 equals x. Put a box on it. All right, I want to check it. You always check it in the original. 11 plus minus 19. Well, it's minus 8. 11 plus minus 19 is minus 8. It does work out. Go to problem number 12. And again, looking at these questions over here, I'm going to say they're one-step problems. Number 12 is 12x equals 4. What would I do? Well, 12 is what's multiplying x, so to get rid of it, divide it away. That's 12. That's 12. You get x equals, well, 4 divided by 12 is going to be 1/3. I'll put a box in that. I want to point out, you check it. And again, remember the original equation is 12x equals 4. How do you check it? You plug it in. This is 1/3 equals 4. Well, if you want, you can put this over 1. 3 goes into 12 4 times, so 4 does equal 4. This checks beautifully. Let's go to 13. And 13 is a decimal number, which a lot of students have trouble with. Some teachers allow you to use calculators. Other teachers do not let you use calculators. Sometimes it's school policy not to use a calculator. All right, I'm still going to write it down for you. I'm going to add 0.9 to both sides. A lot of people say this is doing the opposite operation. That's fine if you think that way. What do you get over here? X on the left side. On this side over here, let's just add it together. Decimals line up nicely. 9 and 5 is 14. And you're carrying the 1, by the way. That's 9, 10, 11. You're carrying the 1, 3.14. If you want, you can check that. 3.14 minus 0.29 equals 2.85. Let's just check it. And to do that, most students have to line that up. Nothing wrong with that. You really can't take 9 from 4, so you borrow it. That becomes a 0. This becomes a 14. 9 from 14 is 5. Well, I got to borrow from the 3 now. This becomes a 2. That becomes 10. 2 from 10 is 8, and you get 2. It does check out nicely. Let's go to 14. And what's problem number 14? And again, there's fractions over here. So it's 4 7s. And then you get what? Equals x plus 1/3. Again, the claim is it's a one-stop operation over here. So it's minus 1/3, minus 1/3. But for a lot of students, this is difficult. On the right side, it's pretty easy. You get x. On the right side, you get something that you might find a little challenging over here. I want to do the arithmetic for you. It's 21 is a common denominator. And then what do you get there? Well, let's just take a look at it. What times 7 would be 21? 3. So 3 times 4 is 12. What times 3 is 21 is 7. So what's 7 times 1? 7. So what are you left off with? Well, 12 minus 7 is going to be 5 over 21. And that's what x is. Again, checking is sort of optional. However, I do want to write this down. 4 7s equals, I'm checking it in the original. And x, I said, is 5 over 21 plus 1/3. 4 7s, 5 over 21 plus, well, I got to make that 21. That's going to be 7, right? 7 times 3 is 21. 7 times 1 is 7. So 4 7s. And what do you get there? 5 plus 7 is 12 over 21. This reduces by a factor of 3. You can get 4 over 7. It does check beautifully. Let's go to 15. And what's 15? It's minus 5. X equals 3.85. What would I do over here? Well, I would divide both sides by minus 5. Let me write that down for you. And what do you get there? X equals minus 3.85 over 5. I want to go through that with you. There's many ways to do it, by the way, but I'm going to do it by long division. I want to divide 5 into 3.85, all right? And just typically how most people do division. 5 doesn't go into 3, but 5 does go into 38. How many times? Well, let's see. That's going to be 7 times, right? 7 times 5 is 35. Then you subtract it, and what do you get there? You get 3. And then you get 35 over here. So what do you get there? 0.77. Let me write this down for you. Minus 0.77. Let me put this down. X equals minus 0.77. Put a box in that. Again, I want to see if it's right. Someone said write down anything you want. See if it's right. So minus 5. Minus 5x, I'm sorry. My pen back. My pen's running out of juice, by the way. Let me get my eraser, see if that works. Give me 1 second over here. Let me get my eraser back out. My pen might be dead. Let me get back over here and charge it up a little bit. Pencil. Let's see what happens now, okay? Well, my pencil's not working. Let's try again. And I got to go back to my system preferences, I think. And wonder why it's not pairing up. And let me see where my pencil is. And let's try to pair it up again. Hide this over here. I'm going to try to pair it again. I don't know what happened. It's a brand new pencil, too. My finger's working. My pencil just died. I'll try one more time, and then I give up. And that's okay. We got to 15. Then we can start up at 16 once I get it repaired. So let me just see what happens over here. It's definitely recognizing when I charge it up. Let me go back to the system preferences again, and let's try that pencil again. All right, it's definitely there now. Sorry about that. Yeah, it's back again. I'm not sure what happened there. All right, so I'm going to get my eraser out and erase this again, and I'm going to check it. And so where do you check it? You always go back to the original. All right, what's the original going to be? What number are we on again? Oh, 15. Let's put 15 down again. It's minus 5 times x. It's the original equation, equals 3.85. So I'm going to check it by plugging it in. By putting an equal sign down, I'm kind of making a statement that it is true. But let's go through it. Negative times negative is positive. And let me do 5 times 0.77. Whoops. I got to get the eraser out again. 5 times 0.77. 5 times 7 is 35. 5 times 7 is 35, so 38. Count the decimal places, 3.85. Yes, we're getting that. Let's go to problem number 16. And again, we're on the one-shot problems. This is x minus 2 equals 3/8. They say it's a one-step problem. What I'm going to do over here is add 2 to both sides. I should write that down for you. So I'm going to add 2 to both sides. Over time, you're going to get quicker at this, by the way, but I'm going to write that adding 2 to both sides. What do you get? X equals, well, 3/8 plus 2. Common denominator, so it's 3/8 plus, well, 2 in terms of ace would be 16/8 because 16 above 8 is 2. And what does it give you? 19 over 8. So x equals 19 over 8. Put a box on it. I'm going to check it too. So in the original, this is the original, 19/8 minus 2 equals 3/8. Well, looking at this thing, let's write this down. 19/8 minus 16/8 is 3/8. And 19 minus 16 is, of course, 3. So it is 3/8. All right? That was problem number 16. Let's go to number 17. And what do you get there? 2/3 of an x equals minus 4. Well, some students, what they do is actually divide both sides by 2/3. I'll write this down this way. I find that to be kind of difficult to look at, so I'm going to make a different recommendation for you, not this one. I'm going to multiply both sides by the reciprocal of 2/3, which is 3/2. What do you get there? Well, on the left side, you just get x because the 3's cancels and the 2 cancels. And then what do you get over there? Well, looking at this over here, if you want to put a 1 there, you can. 2 goes into 2 once, goes into 4 2 times. You get minus 6. All right? Let's go back to the original equation now, and let's see if it makes any sense. And the original equation, I'll just write it down again for you, is 2/3 of an x is equal to minus 4. You plug it in, 2/3. Well, x is minus 6. I'll write it as minus 6 over 1 equals minus 4. Well, 3 goes into 3 once. It goes into minus 6 minus 2 times. And 2 times minus 2 is, in fact, minus 4. All right, let's go to 18. And what's 18? It's 6 equals minus 14x. Let's just look at that and divide both sides by minus 14. What do you get there? X. And on the left side, you're going to get negative 6/14. You should realize that's reducible, and we're going to reduce by a factor of 2, so it's going to be 3/7. I'll put a box in that. I want to go back and check it, and 6 equals minus 14 times x. Well, what's x? That's the original equation, by the way, is minus 3/7. What happens over here? Well, the 7 goes into 7 once, goes into 14 2 times. We have minus 2 times minus 3, which is, in fact, 6. Let's go to 19. And what's 19? It's 3/5. X equals 9/10. Again, my recommendation is to multiply both sides by the reciprocal of the coefficient on x, which is 5/3. What do you get on the left side? Well, the 5's cancel, the 3's cancel, so you're left off with 1x. On the right side, let's just go through that. 3 goes into 3 once, goes into 9 3 times. 5 goes into 5 once, and it goes into 10 2 times. What are you left off with? 3 over 2. It's super easy to make a mistake, by the way. So what I want to do is write the original equation down, which is 3/5 of an x, and they said it's equal to 9/10. Let's write this down. 3/5 times, what's x? 3/2. And what do you get there? Well, you do get 9 on top. What do you get on bottom? 10. It works beautifully. All right, let's go to number 20. And number 20 is 2/7 of an x is equal to 3/4. Again, my recommendation is to multiply both sides by the coefficient on the x, which is 7 over 2. These are one-step operations, by the way. What do you get here? On the left side, the 2's cancel, the 7 cancels. You're left off with 1x. And then you're left off with, let's see, 21/8. I want to check it. It's number 20, so it's 2/7 of an x is equal to 3/4. 2/7 times 21/8. Well, let's see. Again, I'm making an assumption it is 3/4. Let's see. 7 goes into 7 once, 21 3 times. 2 goes into 2 once, into 8 4 times. So you do get 3/4. All right, so I think at this point, we finished the first 20 problems. I'll put a line over here. I just want to go back to the original problem set and just tell you what we just did. And we just finished off these ones, the one-step ones, all right? You know, they kind of started easy, and then, you know, some of them got a little more difficult with the arithmetic, but they weren't too bad. It's all one step, right? Except for the checking. It must it's an additional step. And then we're going to do these things over here, all right? Now, these things, they say it's two steps. What does two steps mean? There'll be two steps to do the problem. Thank you.